Okay, in this video, we're going to use a program called mfold to help us find termination loops, the little hairpins. Now, this is difficult, and I think you'll see why, because you have to interpret the results. Now, we're still going to use our very simple version, and you're going to see that, yes, it's going to find our loop, but it's going to find some other like structures as well, and you have to figure out if is what you're looking for. But the program we use is a common one used in, but it's, like I said, it's the one most people use. It's called mfold. We're going to be doing RNA. Our always have T's and C's, and we're going to look for an RNA where the loop to form the loop forms in the RNA. The DNA, if it forms a loop, really doesn't affect, we don't think, very much the termination. It's actually when the RNA forms and forms the loop, that's what makes the polymerases fall off, and perhaps even ribosomes as well. With the idea of the stop codon, there may be something in there to assist in altering how the ribosome works, but that's for a different lecture. We're talking mainly about transcription at this point, and that means RNA polymerase. So what we want to do is we want to come to this page. You saw how I got here, and we'll give it a name. We'll use exactly the name I used before, termination 1 example. And what we're going to do is we're going to paste in our sequence where we think the termination is located. So you'll be doing this with the black operon. You'll be going to those regions that you've identified in between Z, Y, and A, or at the end where A is. The pieces between Z and Y, a piece between Y and A, and then at the end I'll actually give you a paper where it just tells you what the final one, the A terminator, is. You probably should just take that piece and run it in here just to confirm that this says the same thing that that paper says. Then you need to find the one between Z and Y, which will be hard to find, though that paper helps you out and helps you find them, and then confirm it using this program. And then, of course, the one between Y and A, that one also. So those two need to go in here. The paper will help you find them. They actually give it to you, but you need to confirm it using this software. So what we're going to do is we're going to put in our sequence that we used before, the one we understand right here, all A's, all T's, G's, and C's in the middle. And we're going to just use all the normal parameters. We're not going to change anything. And we're going to, we're not going to format anything. We're going to go down here, all right, and we're just going to say fold RNA. And we'll wait a few minutes, not minutes, and here we got an answer. For your output, and you want, you can PDF or JPEG, and we actually instructions. It said we figure it, what that's telling you is it couldn't figure it out if this is the one that would form or this one, but if we made that little piece artificially, this is what it predicts that its shape would look like. So let's look at it as a JPEG in structure 1. And this is what you would turn in. You would take this JPEG, and sure enough, what it did, it said, here, look at all our A's, look at all our U's, even the GC here, right here. Here's our little loop. But look, it said the whole structure, if you took that piece, it actually would form a much more complex piece. There were other places that it could bind, even places with a U and a G. That's not normal, right? But it said this is what the computer simulation says would actually form if you were to take that little piece of RNA and make it artificially. This is what it would look like. So this is, of course, very interesting, and this is its first predicted structure. It said there was a second one, so let's go back and see what the second one looked like, see if it was different. And yeah, more of what you expect, but even that's pretty complex. Here, of course, are all our T's that they're used here, and A's. Here's our GCs that we put in the middle. So here's our little terminator, but look at all this other stuff that it found and put it together. So RNA there that we made was it looked by your eye. It didn't look. It would be binding much like a hairpin. Thing folded up nicely. Hairpin all by itself. Thing would be. That's something you can tell it would. So this is what you're looking out for. Now you can take these JPEGs and save these images so you can put them in. So that's the. Oh, that's fine. Size. But that's what I expect to do on your report. To just find the sequence where you think that the coordinator is through here, and put these JPEGs in the report.